All right, so taking what you know about perimeter, the distance around, area, the amount of space on the inside, so two-dimensional. Today we're talking about just rectangles with the same perimeter. How does that affect the area? So up here I included a picture of something you guys might draw. So it says on a centimeter dot grid, so draw all the possible rectangles with a perimeter of 12. So if you look at this one has 5 centimeters. So 5 and 5 is 10, 11, 12. So that's 12, a perimeter of 12. 4, 8, 9, 10, 11, 12, a perimeter of 12. 3, 6, 9, 12, a perimeter of 12. They all have a perimeter of 12. Now, 3 very different shapes. So we have a perfect square, a 3 by 3. We have a 4 by 2 rectangle, and then we have this kind of long, skinny rectangle, a 5 by 1. Now, if we were to find the area of all of these, so I'm just going to write these into our grid here. So we have a lengths of the 2 adjacent sides. So we have 1 and 5, we have 2 and 4, and we have 3 and 3. And those are all in centimeters. So if we look back up here, now I'm going to zoom in. If I were to draw by connecting those dots, we would have 1, 2, 3, 4. That would have an area of 5 square centimeters. This would have an area of 2, 4, 6, 8 squared centimeters. And this one would have an area of 9 square centimeters. So although they all have a perimeter of 12, 12 and 12, they all have different areas, so the amount of space on the inside, so 5, 8, and 9. So I could ask you, so 5, 8, and 9, which one has the largest area? And you should be able to go in and say, ooh, it's the one that has the adjacent sides. So adjacent would be like neighboring sides that are closer together. So that 5 and that 1, the length of the sides are so different. 2 and 4 are closer together, so you get more area. 3 and 3 exactly the same, so you get the largest area. So if you were to take, think of even your house, some of the rooms that you have, the area of some of your biggest rooms are going to be the area that are closer to the adjacent sides being the same. All right, so this one you would have rectangles with a perimeter of 24. Now you don't have to have the dot paper, 22. So you could do one long skinny one. So it'd be 10, because if this side's 10, this side's 10. So that'd be 20, 21, 22. So you'd have this long skinny rectangle. Now the area of this one would only be 10. Kind of like this one, a 5 by 1 is only 5. 10 times 1 is 10. Now I could go down and figure out another one. So if I did, like, let's say 8 and 8, so that'd be 16, 17, 18, 19, 20, 21, 22. So I'd have 6 more that I would need to add to get a 22. So I could do a 3 and a 3. So if I did a 3 and an 8, oh, that's not right. So that one would have a perimeter of 22. So if I have 8 and 8 is 16, 17, 18, 19, 20, 21, 22, perimeter of 22. The area of this one would be, I'd have 3 rows of 8, so the area would be 24 square units. So it goes up, more than doubles. I could do 9 and 9 is 18. 19, 20, 21, 22, so I'd do a 9, 9 and 9 is 18, 19, 20, 21, 22, so a 2 and a 9. Now the adjacent sides are further apart, So it's going to be in between that 10 and that 14 for the area. So 9 times 2 is 18. So then if you were to do one that's a little more, well, I guess, square shaped, like let's say you do a 5 and a 5, that's 10. Then you would do so 10 and 12, so a 6 and a 6. So 6, 12, 12 plus 10 is 22, so 6 times 5, so 5 and a 6 is going to have an area of 6 rows of 5 or 5 rows of 6 is 30. So compare the shapes. The least area is the 1 by 10. The greatest area is the 5 times 6. 10, 30, so it's 3 times bigger. It's kind of interesting. The more square the shape, the bigger the area is going to be. So you're really just continuing your work on 342. Just trying to connect that idea of perimeter and area.